All right, boys and girls, this is a refresher lesson on inverse trigonometric functions. In Magnet Advanced Algebra, you spent several days on finding the inverses of functions, and at the end of the school year, you spent some time on working with inverse trig. So this should be a refresher lesson for some of you all, or for most of you all. We know that when we're working with functions, in order to take the inverse, the function has to be 1-to-1. 1-to-1 means that every x and every y are only used one time. And if you look at the graph y is equal to the sine of x there on your worksheet, you can see that the y values are repeated over and over and over again. That's what makes them periodic and cyclical, or what makes those types of functions periodic and cyclical. Therefore, we still can create the inverse, but we have to restrict the domain of the original function. So let's look at y is equal to the sine of x here on your worksheet. In order to create the inverse, we're only going to look at the piece of graph from -pi/2 to pi/2. So just that tiny piece. If we went any further if we went greater than pi/2, the pattern would start to repeat, the y values would start to repeat, and it would, when we created an inverse, the inverse wouldn't be a function. If we went less than -pi/2, the same thing would happen. The y values would continue to repeat, and our inverse would not be a function. All right, we also know from our work in Magnet Advanced Algebra that to create an inverse, we switch the x's and the y's, which is what I've done here in setting up the inverse. X is equal to the sine of y. Well, that's actually kind of awkward. So we're going to write this as y is equal to the inverse sine of x, or y is equal to arc sine of x. Either one of those are seen both in pre-calculus and calculus. All right, let's get a sketch of the graph of the inverse sine of x. We're going to switch the x's and the y's. That means that on the x-axis, the values -1-to-1 will show up as they showed up on the y-axis for the sine of x. And on our y-axis, our angle values will show up. So from -pi/2 to pi/2. All right, so we're going to reverse the x's and the y's for the ordered pair over here on our regular trig graph. All right, so this ordered pair would be -pi/2, -1. This ordered pair is pi/2, 1. So we're going to switch the x's and the y's, and we're going to plot -1, -pi/2. So that point you see right there is that. We're also going to plot 1 pi/2, and that point is right there. And this curve is going to look something like this. All right, and that is a function. You can see that if we continued on either greater than pi/2 or less than -pi/2, we would no longer have a function. All right, what's our inverse function's domain and range? The domain only runs from -1 to 1. No surprise there, because when you switch the x's and the y's, you're switching the domain and the range, and that would be the range of the sine of x. However, our range is restricted because we restricted the domain of the sine of x, and it's restricted to -pi/2 to pi/2. All right, for a minute, let's look down here at the practice problems and see what we have. What we have is a question about the inverse graph, and I am giving you a x value. I'm giving you an angle value, so the answer is an angle, which on the inverse trig graph is a y. Okay, so it's just like a special angle question, except we switch the x's and the y's. It's really just that simple. All right, we can see if we look up here at our range, at our possible answers, it's highly restricted. We don't have many choices whatsoever. So what can we choose? Let's put the unit circle here on our worksheet. So we can have no angles less than -pi/2, no angles greater than pi/2, and so we can have angles in between. If you're given a positive value, the answers are going to come from the first quadrant. So that means 0 is a possible answer, 0 radians, pi/6, pi/4, pi/3. Those are all good answers. If you're given a negative value, that answer is going to come from quadrant 4. That means we're looking at negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. All right, I'm going to do the first problem with you guys, and then I'm going to let you try the other ones on your own. So I will pause the video and put the answers up, and then I would ask you to not look at the video while you're doing the work, and then look back up at it and see if your answers match mine, okay? All right, so I would ask you to look at the responses and see how you did. Circle the ones that you might have questions about. You may have questions about 5 and 6, but just very quickly, what I've done is I've answered the inside question. Here on number 5, I'm circling the inside question in red, and on number 6, I'm circling the inside question in red. That's an inverse trig question. I've come up with an angle value. So the angle whose sign is negative 1 over the square root of 2 is negative pi over 4, and now I ask the outside question. So this is really just actually kind of a composition of inverses, which means we wind back at the same question. Now number 6 is slightly different, but I handled it just exactly the same way. I answered the inside question, which gives me an angle, and then the outside question is simply a special angle question. All right, we are actually going to jump over to tangent, because tangent behaves very similarly to cosine because to sine, because they're both odd functions. Cosine behaves differently because it's an even function, and we discovered that. All right, what we're going to concentrate on is what I call the central period. Let's dash in the asymptotes. By the central period, I mean just this period right here. All right, that's the one we're going to take the inverse of. All right, so you see I've already switched the x's and the y. X is equal to the tangent of y. A better way to write that would be y is equal to the inverse tangent of x, or y is equal to arctangent of x. All right, now if they're vertical asymptotes on the tangent graph, they are horizontal asymptotes on the inverse tangent graph. We know that the range of the tangent function is unrestricted. That means the domain of our inverse tangent function is unrestricted. So the curve is going to look something like this. All right, so let's identify its domain. Negative infinity to infinity, switching the x's and the y's. And the range, very similar to sine, runs between negative pi over 2 and pi over 2, except we don't include the endpoints on tangent because tangent's undefined at odd multiples of pi over 2. It doesn't matter that it's inverse trig or regular trig. All right, so let's draw a unit circle and get these angles labeled. What's available to us? Well, we can go up to but not including pi over 2, go down to but not including negative pi over 2, 0 is included. For positive values, we're going to pick up in quadrant 1, just like with sine. We're going to look at pi over 6, pi over 4, pi over 3, but not pi over 2. For our negative values, we're going to use the negative version of quadrant 4, which is negative pi over 6, negative pi over 4, negative pi over 3, but of course not the endpoints. All right, so again, I'm going to pause the video. I'm going to let you answer these questions, these practice questions. They answer just like the sine questions we did. And then after you've answered the questions, look at the video and see if you agree with my responses. All right, again, I think the only ones you might have trouble with would be 5 and 6. Remember that the inside, here I will circle this in green. This is a inverse trig question. Find that angle, and then once you found the angle, it simply becomes a special angle question. Again, on number 6, find this angle, and once you found that angle, then it becomes a special angle question. All right, let's go back to cosine, inverse cosine and cosine. All right, cosine is an even function. We're certainly going to switch the x's and the y's just like we did before, but you can see if we went from negative pi over 2 to pi over 2 like we did for sine, when we switch the x's and the y's, that's not going to be a function. That will not pass the vertical line test. So that's not what we want to do. That is not where we want to be. For cosine, we're going to go between 0 and pi, and we're going to look at that bit of the domain, just that bit of the domain. All right, so this is the point 0, 1. This is the point pi 0. I'm sorry, not pi 0, heavens, pi negative 1. And those are the points we will plot by switching the x's and the y on the inverse cosine graph. So, of course, it's called the inverse cosine of x, or arc cosine of x. All right, so let's label the x-axis. The x-axis will no longer have angles on it. It has values on it, just like sine does. The y-axis no longer has values on it. It has angles on it. All right, so instead of plotting the point 0, 1, we're going to plot the point 1, 0. That's over here. Instead of plotting the point pi 1, negative 1, we're going to plot the point negative 1 pi, and that's up here. Of course, this is going to pass through the point pi 0 pi over 2, and it's going to look something like this. All right, just like sine, the domain is between negative 1 and 1, but our range is different. This is an even function. Our range is from 0 to pi. All right, what does that mean from a unit circle standpoint? All right, that means we're going to look from 0 to pi. Our positive values, just like sine and tangent, are going to come from quadrant 1. So we're looking at 0 is fair game. We're looking at pi over 6, pi over 3, pi over 4, and of course pi over 2 is fair game. If we're looking for negative values, now those come from the second quadrant. These angles that we're accustomed to seeing: 2 pi over 3, 3 pi over 4, 5 pi over 6, and then ending with pi. So very, very different. And you can see, look, here these angles between pi over 2 and pi. These angles right here, they are second quadrant angles, and that is why we can use those as answers. All right, again, I'm going to pause the video. I'm going to put my answers up here for the practice questions, and then you practice without looking at my answers, and then check yourself to see how you did it. All right, so let me pick back up. Let me, let's see, let me go over to the first page and scroll down so you can see the answers to 1, 2, and 3. You can see number 3, that was a negative value, so it came from the second quadrant. Be careful. Let me note here on the cosine graph that no negative angle should be used as an answer. Let's make ourselves a note there. No negative angles. All right. Okay, and there is the 4, 5, and 6. Again, 5 and 6 is just about answering the inside question, which is an angle question, and then the outside is a special angle question. All right, so let's summarize what we have here. Our inverse function, y is equal to the inverse sine of x. Our domain is from negative 1 to 1. Our range is from negative pi over 2 to pi over 2. And the quadrants we can use is quadrant 1 and quadrant 4. Y is equal to the inverse cosine of x. The same domain as sine. Range very different from 0 to pi. Quadrants to be used: quadrant 1 for positive angles, quadrant 2 for negative angles. Or not negative angles, negative values. Quadrant 1 for positive values, quadrant 2 for negative values. Y is equal to the inverse tangent of x. Unrestricted domain, highly restricted range. negative pi over 2 to pi over 2, not including the endpoints. Quadrant 1 for positive values, quadrant 4 for negative values. These are the same because they're both odd functions. The problems on the bottom here we will do together in class to keep the video at a reasonable length. See you guys later.